in charge of training and evangelism at JET, and this is a little bit about our chaos engineering program. So first of all, why do we even need chaos engineering? It's, you've tested there's a lot of different ways of testing. There's BDD testing, there's a lot of different things. But we really should test and make sure that all of our different components really interact with the world out there today, which is very chaotic. If you're building systems at scale, have you tested for failover setups? Have you tested your timeouts? Have you tested to make sure all of these things are actually going to work? All of the manual testing and such that you can do isn't necessarily going to find something like CSS failing because of a timeout. So, things like this are very important to test for. In fact, part of how if you folks remember the Volkswagen scandal, was that a year ago? Part of the way that they actually detected that was that the tests were too perfectly uniform. There was no chaos in any of the testing. And this is something that you really need to look for. And if they'd been smart, they would have added a little chaos. It's super important to test that these interactions actually work in your environment. And just because you've tested that the light works and the light fits in the spot doesn't mean you're going to forget to not build something right in front of it, right? So stepping back, JET, who are JET or who is JET, depending on if you tend towards the American or the British phrasing there. We are a startup, New York-based startup. We're an e-commerce company intending to take on Amazon. We launched in July of 2015, and just in August, just a few days ago, the paperwork was actually finished. We were purchased for $3.3 billion. We are primarily an F# shop. I'd say about 95% of our backend is F#. We're heavily focused on microservices as well, the #4 marketplace worldwide. I say we have 700 microservices. That's kind of a made-up number. I know for a fact about a year and a half ago we had maybe 350, and the teams have been expanding and growing. And so I asked about 6 months ago, what our new numbers were, and all the teams, everyone I asked was just like, I don't know. My team has 95. My team has 42. My team has 78. And so I sort of averaged those numbers around the team and came up with somewhere between 500 and 1,000 microservices. So 700 seems like a good average number. Like I mentioned, we're heavy users of F#. We're also heavy users of a lot of different technologies. Azure, to be one. We are, as I mentioned, intending to compete with Amazon.com. So we are not heavy users of AWS. But we use several of the F# libraries, and then so the top section is the Azure stuff. The green section is our F#. We do still use R and Python for our data science. We still use Node and Angular on our front end, and then the purple at the bottom is sort of our everything else technology. So we are not afraid to try something new to see if it could be the right tool for the job. So I usually have a very long section in here on why F# and why this is actually good, because I tend to be speaking to audiences who are very heavily object-oriented and maybe on the C# stack. But I did want to show a couple of my most favorite slides, just so that one, you guys can have a few more anecdotes, and two, because they're really a lot of fun. So my favorite story, Simon Cousins. I've now delivered 3 business-critical projects written in F#. I'm still waiting for the first bug to come in. He first wrote this. He discovered F#, found a perfect use case for it, went off into a corner with 3 of the other devs on his team, and rewrote an entire application. They ended up delivering it over to the business and never heard anything back. So he contacts them about a month later. I was like, are you using this? Is it unusable? What's happening here? Did it meet your requirements or not? They're like, no, it's fine. It just works. What are you talking about? It has all the features we requested. We haven't found any bugs yet, so we didn't bother to say anything. He first wrote this about 3 months after that first interaction, and it's now been more than 3 years, and he still has had no bugs. So one of my favorite functional programming stories. Also a accidental complexity story. This is TICSpec, excuse me, a BDD testing project written in F#. This is a very simple diagram to show you. You can follow it around, see which bits of code depend on which bits of code, a dependency diagram. This is a very similar BDD testing project written in C#. I haven't compared them, feature for feature, but obviously F# is much more, it's much more easy to see what's actually happening there. And then if you folks saw the Stack Overflow survey that came out a few months ago, 4, 5, 6 months ago, most loved languages were heavily focused on functional programming. So folks just love functional programming. And Swift is up there. F# is third. The Scala enclosure and Haskell. There's a lot of just love for functional programming. And I know we all know this, but like I said, these are some of my favorite slides. So what actually is chaos engineering? And a lot of people think it's just wreaking havoc with your code because it's fun. Let's shut down a server and see what happens. Mwahaha. And while I admit that is kind of fun, it's, breaking things, especially developers, as we know, like to, think that breaking things can be bad, and that causes a lot of inconvenience. And, this is no good. I once worked for a manager, this poor person, who was taking over from a previous manager who had worked in the department for 10 years. The prior manager decided that upgrades were bad, all upgrades for everything, because they break things. So chaos engineering is breaking things. And, it's a lot of folks have this, what could possibly go wrong when you're breaking things? But really it's about testing. It's controlled experiments to see what is going to go wrong. It's very much like, your standard QA testing. Let's try to order -1 of something and see what happens. And this is, especially with a distributed system, it's important to test on a larger scale and test these interactions with different pieces of code to make sure that this is all actually going to work in the long term and at scale. So it's a lot more like a controlled burn. I don't know if you folks do these, but in the American West where I'm from, forest fires are a huge problem. And so every year or so, forest fires, or the firefighters will light a small controlled burn to make sure that, so this section has been burned out so that if a forest fire comes through, it doesn't just ravage hundreds of miles. It can only reach as far as, into the pre-burned sections. So chaos testing is very much like a controlled burn. You're controlling the way that you break things so that you don't, end up with a massive, an unfettered disaster later. So the principles of chaos engineering. First, it's important to define what the normal state of something actually is. Maybe it's if you're going through a shopping cart, it's being able to place an item in the shopping cart and then eventually being able to purchase it. It can be as simple as that. Next, assume that normal will continue in both a control group and an experimental group. Assuming that you wreak havoc with your code, that nothing will happen and everything will continue as normal, hopefully. Third, introduce chaos. Have something that simulates servers crashing, hard drives malfunctioning, network connections that are being severed. You want to be able to test all of these different things that may or may not be working at any given time to see what actually happens. And if something goes wrong, if you are able to not place an item in your shopping cart, if you're able to not follow through with the full purchase, then that's a problem. Look for a difference in behavior. Maybe it's even, maybe it's even just a timeout. Maybe it took, or something slows down. It's not bad, it's not the end of the world, but it did make things a lot slower, and that's not a great experience. So you can, it doesn't have to be crash and burn or perfect. There are many levels at which you can be testing these things. So the benefits of chaos engineering. First, you're awake. When when you're, the chaos engineering team is taking down a server to simulate something, or shutting down an instance of a service, the devs who would normally be working on this are awake. It's 10 a.m. or 2 p.m. You've had your coffee. You're sitting in the office. You're ready to go. You might be working on something else and it's inconvenient, but it's not 3 a.m. It's, you haven't been woken up by a PagerDuty call and something massive has gone down and you have no idea what's happened. You need to wake up first and then try to understand what on earth is even going on. So you're awake is the first and I think almost most important part. And second, as chaos starts to become part of the culture that you're really working with, and within your dev team, devs will start to design for failure. They know that the chaos testing systems will start to test their services and test to see what happens. And so you'll start thinking about, well, when chaos comes through and shuts down these 3 instances, is that going to be okay? Is everything going to fail? Do I have proper failover set up correctly? You start thinking about these things in advance of going into production. You end up with much healthier systems. As you're thinking about these things in advance before you go into production, you pre-solve a lot of the issues that you could possibly have had. And then, self-service. Again, as you start to further along all these things, a lot of devs will come back and sort of have a mini competition with themselves. I was caught by this one thing last time that I didn't think of. How can I make the most resilient, most amazing service in all of the team? And you start, you want to test for failure because you want to know how well you've done this time. But basically, if availability is something that matters, then chaos is something you should be testing for. It's really a best practices kind of move. So current examples of chaos engineering, and this I thought was fun. I went to Google, what is chaos testing, just to really make sure I fully understood the topic. And Google was just like, you mean Chaos Monkey. There is no other example than what Netflix is doing with chaos engineering. So they have a whole bunch of related products. Chaos Gorilla will simulate an outage of an entire availability zone with AWS. There's also a janitor monkey that looks for unused resources and cleans those up. There's also, in addition to Chaos Monkey, there is a WAS monkey that works on Azure. But it wasn't good for us when we started to, we ended up rolling our own program. But when we started to look at this, it would only stop an entire cluster. And we wanted to really ease into the process of chaos testing. Maybe just stop an instance. Like we don't need to, drown the devs in things breaking. Just sort of bring this on slowly. We also wanted to be able to leverage all of the F# architectural, all of the architectural products that we have, and chaos eventually should be part of the continuous integration cycle, all of those sorts of things, and we wouldn't be able to do that with WAS Monkey specifically. So how is Jet different than these products? Well, one thing that I will often mention is that and one thing I know that Netflix has said, it is very, 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 very important to not only, but to be certain that you're testing in prod, because you can't really simulate an environment and things will be different. And so if you're testing something in QA and then you try to test it out in prod, you're just going to find different things. So you might as well find a safe way to be working in prod. So we are not testing in prod yet. It has taken, there's been a big socialization. Lots of socialization has been needed. A lot of the dev teams are not convinced that random breaking of their products is good and necessary and not just evil. But we are working our way up to that. I know the chaos team feels that it is very important to be testing in prod, but that is an eventual stage. And one other point is, because it's so difficult to have an exact backup of QA, there's always going to be small differences and slightly different things that it's too expensive to maintain a complete, full, exact copy that is 100% the same as both in both prod and QA. We are, though, using both Azure and F#, and I know this is something that none of the other products use and aren't really working on. So that's one big win. So here's what some of our F# code actually looks like. We have a single microservice. I mentioned we have the 500 to 1,000 microservices. So within one of these, we have this select random instance function. Compute here is a type compute management client, which is one of Azure's ways of handling hosted services, locations, virtual machines. So that's how we get into the Azure ecosystem. And the hosted service is the actual hosted service that we're working with. There was an additional bit of logging here. We're checking for only one service instance role and then not restarting that, or we are restarting it, but there's a lot of extra logging in here. But the meat of this is, we're getting the hosted service details, and then we're getting the production deployment details. And from the deployment, we get how many instances are up, and do a random pick of how many instances that service has, and then return that information. So we're just selecting a single random instance of a service to restart. And then from the restart random service function, we first call the select random instance. So we need a random instance to be able to restart it. Get back the service name, deployment ID, and role instance, and just do a simple match there with whether or not it stopped or already started. If it stopped, then we're not going to stop it again. That would be silly. But otherwise, we restart that service and see what happens. And a bit of logging at the end. The main and sort of most important bit of code is a lovely just pipeline. We're starting with the compute information. We're getting all of the hosted services, and then we're filtering for an ignore list. So if there is something going wrong or going on, and you need to, you're really working heavily on a production push, and you don't want chaos to mess with anything, you need to know exactly that what you're doing that afternoon is working, then you can have chaos stopped on your work for a single day. And that can be continued for a few days, but the management will get involved if it's much more than that. So we filter for the ignore list, so you can get a reprieve. We do a simple Nuth shuffle, and I didn't actually know what a Nuth shuffle was. It's a delightful little piece of code, but it basically just shuffles the services around, do a distinct by, and then use that distinct list to grab call the restart random instance bit of code, and you restart one of those in an async computation expression. The async parallel ignore is something that we have written at Jet. I believe it has been open sourced, but this specifically, the ignore part, it doesn't keep track of the results of the asyncs that it executes, so we can schedule an unbounded sequence of them. It does allow us to place a bound on the parallelism, which is the one. One of the things that this is really super useful, because too much parallelism can really create a lot of contention and reduce the throughput, increase latency. A lot of that will get bad. So here we do one, but you can set up exactly how much you need. Finally, it'll start each computation specifically on the calling thread. So in general, that's faster. It isn't always, but it's in general it is. You can switch to the thread pool with using a different command, and then at the end we just call async run synchronously to actually run all of this. So has this all helped? First, and I will go through this a little more quickly so we have time for questions, but we did have a major, just total breakdown of Elasticsearch. The manual testers that we have were testing something specific, the searching. They were noticing that search wasn't resulting in data. And then the pricing team started to see timeouts. And search noticed search wasn't handling those timeouts. And it just cascaded, and everything just sort of ballooned. It ended up that Elasticsearch was down and had been cascading these issues out. And Chaos was the one that had restarted Elasticsearch. So it was the Chaos team's fault entirely that all of this, well, not the Chaos team's fault, it was the developer's fault for not planning for it, haha. But it was because Chaos had tested this, it tested what a restart would look like. So it took days for DevOps to get QA back up and everything running again and everything back in order. There were also a couple other issues, but I will not go into them now. So basically, if availability matters, you should be testing for it, as I've mentioned. And really, in conclusion, Azure and F# and Chaos is happy. Any questions? And one small comment. Nora is one of the, that is her name, she is one of the major developers on this code, so you guys should definitely go check her out if this is something that you are interested in. And
Hi, Tyler Dromboski from Fugue. I really love the idea of chaos, and it's something that we're trying to get to at our own company. The question I have for you is the space of chaos is very large. So kind of two parts. One, how did you describe what your initial atom of chaos looks like? And two, are there any other forms of chaos that you're looking at testing in the near future?
So the two questions were, basically how we got started and what we're looking to expand to in the future. I'll answer the second part first. I would say definitely, I think one of the major goals is really to get into production. Chaos has started to show its worth, but it's still, as an e-commerce site, there's a lot of hesitancy. If anything goes down, if something like the thing we're if it takes days to get the site back up, that's a huge issue. So a lot of folks have been very hesitant with that. But I would say that's probably the biggest thing. Where we started, I am not 100% sure. As I mentioned, I am the chief evangelist. I am not on the team. My guess is it started very simply with, restarting a single instance of whatever has been happening. Just let's take a list of the 10 services running on, 400 services running on this machine and see, restart one and see where that brings us. I know that now the program is, I think it starts at 9 and ends at maybe 4 and just runs automatically all day, just sort of randomly restarting things.
Cool, thanks.
Sure.
Hi, I'm Scott Fritchie with VMware Research. How much more work do you think that it will take to change the corporate culture to get this testing into production? I know Casey Rosenthal at Netflix, and I've also heard at Chaos Engineering Days that at Microsoft, you can get a reprieve from senior management, but it's like literally a day, and then sorry, there is no more exception after that.
So the question was, how much more culture do we have to overcome, basically? And it's, I think, quite a bit. I think my understanding, again, is that senior management is still hesitant, has bought into the idea in concept, but it'll need a lot of very small baby steps to, again, restart one tiny thing that we're 99.4% positive is going to work anyway.
So are the Azure hosted services, are they just a little bit too stable to make this worthwhile? Because people complain about AWS stability all the time.
So are the Azure services a bit too stable? I would say it's probably the opposite. There have been several jokes made that Azure is its own chaos testing, and that has actually been quite good for the company.
Thank you. All right, that's all we have time for, so let's thank Rachel.